Hey guys, today we're going to be doing a significance test for the difference of two means. So we have this information, texting teens versus people in their 20s. We have a group of teens, which was randomly sampled, a group of 40, and their mean was 94 and their standard deviation was 18. And we also have a randomly sampled group of 60, where their mean amount of texts sent per day was 89 and their standard deviation 15. So our question at hand is, do teens text more on average than people in their 20s? And what we're going to do is first use that question to drive our hypotheses. So our null hypothesis is going to be mu, and I'm going to just, instead of using 1 and 2, I'm going to use mu t for the teens equals mu, and I'm going to put a little 20 next to it to denote teens and 20s. Or I could have written this as mu t minus mu 20 equals 0. That states there is no difference between the true mean amount of text the people in their teens and 20s send. Our alternative hypothesis is that mu t is greater than mu 20, or mu t minus mu 20 is greater than 0, because it asks, on average, do teens text more? So because that more is there, our alternative hypothesis has to have a greater than sign. Let's take a look at our conditions. The randomly sampled two independent groups, that checks out. So the teens and people in their 20s that are independent of each other, the 10% condition, and then our large counts condition, all check out. So from there, we are going to start dealing with our formula for finding this t-score to see if what our results are significant or not. The broad formula for this is that t equals x bar 1 minus x bar 2 minus mu 1 minus mu 2. In this case, we're assuming our claim was that this is 0. And then all over the square root of s1 squared over n1 plus s2 squared over n2. If I plug what we have into this formula, we get 94 minus 89 all over the square root of 18 squared over 40 plus 15 squared over 60. And then if you were to work this out, you get a t-score right around 1.45. And so if I were to draw a little picture of this, I have 1.45, and I color in more extreme than that. That's what my picture looks like. And from there, if I looked up that p-value, we could find that as well. If you were using a calculator, keep in mind you would use 2SAMP t-test. Once again, we're using a t-test because we do not know the population standard deviation. So 2SAMP t-test will give you your t-value of 1.45 and your p-value of 0.0753. So now we can make a conclusion off of that we fail to reject H naught since 0.0753 is in fact bigger than 0.05. Therefore, we do not have evidence of the teens texting more. So there you have it, a complete significance test for the difference of two means.